be able to, your technology should be able to support manufacturing bigger components also. Alright? Yeah. So wide range of printable materials and non-proprietary materials, that is what I was talking about. The material should not be proprietary, okay? So you should have multiple sources to source the materials so that you will get the material at a cheaper rate, alright? Of course, maintaining the quality. So printable materials also, wide range of materials you should be able to print. If your technology says I can only print plastics, it has limitations, okay? Your technology should be able to print metals, plastics, ceramics, okay? Even biomaterial, that is what your workshop is, okay? Biomaterials, biocompatible materials, this piece. Yeah. So the specialized processes, customized machines, application specific solutions, these are all, part of the current status of the additive manufacturing. So the additive manufacturing is no more a rapid prototyping. It is now, it has gone into the industry already. Okay, people are using it now in the industry to some limited extent. Okay, not for everything. Yeah. So unique benefits or capabilities of 3D printing, we can list as follows. It is very rapid. In few hours, an idea can be realized. Okay, an idea can be converted into physical reality. Okay, so what you see is what you build. Even what you don't see, actually, what you conceptualize in the mind, you will be able to produce it. There is no limitation as such. Manufacturing simplified, so fully automated and unattended operations. Operator need not be there. He can just switch on the machine, okay, load the material, switch on it. Come tomorrow morning, okay, the component will be ready, right? No part specific tooling, any component, same machine you can use. Last minute changes very easily can be accommodated. Reduced number of process steps and resources. Okay, there are only three things: build the solid model, slice it, and then print it. That's all. 3 steps. Reverse engineering is very much possible. Cost effective and time effective. Significant savings in the materials, because material wastage is very minimal in this case. Okay, support material is what you are going to take it out and then so otherwise you will be depositing whatever is necessary to realize the component. So geometrical freedom, you have no restriction on the part geometry. So in fact we say in 3D printing the part complexity is free. Part complexity is free. Okay, you don't have to worry about the complexity in the 3D printing process. So reduce the number of parts, assembly costs, and logistical complications, all that. So in fact you have a product in which various components, they will be having relative motion. Okay, in the conventional scenario, how will you think of it? Fabrication, you produce different components, bring them together, assemble them, and realize the product. Okay, in 3D printing you can build the entire thing, all the components with relative motion in one go. No assembly required. No assembly required. Okay, that is the beauty of this particular technology. Next. So the better properties and performance you can achieve with the components. Design innovation. So you can design how much material is required in this particular section of the component. Okay, what sort of design changes are required. All those things you can do. Okay, as far as the design is concerned. As far as materials innovation is concerned, you can produce the parts with functionally graded materials or multi-materials. A single component, it may have different materials at different locations, multi-material. Or you can have, let us say, one material will be 100% here, material A, material B 100% here, material B will be slowly diminishing, material A will be slowly increasing like this. So you may achieve this kind of gradients. If you feel some property is required here at this end, corresponding material you use a different property altogether. For example, in the case of aircraft body, okay. Inside you have some conditions, outside you have altogether extreme or very harsh conditions, okay, especially in the case of rocket materials, all that. So outside the material will be experiencing a lot of temperature, friction, all those things. Inside its conditions are different. So from outside to inside you need to have that gradients, right? So such things we call it functionally graded materials. Microstructural design. So material, not only just using the material, what kind of microstructure is required at which region. So you can design the microstructure also to that extent. Okay, that is possible. Customization, yeah, because when we talk about body parts, different people will have different dimensions. Okay, for example, knee joint. Okay, we have different dimensions and little bit of geometric variations, all that. So you can produce them prosthetic implants suited to particular patient. Okay. Next, on-demand manufacturing, make things then and there. For example, Mars rover 2020 it was launched. Okay, it was sent. Okay, so 3D printer also was part of it, because if something goes wrong, your 3D printer has to manufacture that and use it, because nobody is there in the Mars, right? So your 3D printer is going to help in manufacturing or repairing a particular component. So you can see the exciting applications of 3D printer. And the reduced inventory and storage costs, no lead time issues, because you don't have to maintain too many components in the inventory, thinking that supplier may not supply next month, so you buy more. When you buy more, you have to maintain them, because every component, every spare part will have its own shelf life, isn't it? So you need to maintain them, warehousing, okay, pilferage, all those things, material spoilage, all that. But here, whenever you want, you just produce at that time. You don't have to maintain too much of inventory. So micro manufacturing, it supports household technology. You can manufacture different household items using 3D printer. Next. So material options, you have metallic materials, polymers, you have biocompatible materials, and other materials like ceramics, all that, elastomers. So you have wide range of materials which are possible. So coming to the applications of 3D printer, I don't know how much time I have. I can go? Okay. So you can see the spectrum of applications that 3D printing technologies have got. You can see all almost all the sectors you can use this particular technology. Yeah. So this is the ornamental objects. Okay, we don't produce as such the ornaments using the 3D printing. We produce the dies. Okay, once the die is ready, you can produce any number of components. Okay, for a different component, another die we can easily produce the dies. Okay, these ornamental components, the shape, the complexity, as you can see, very difficult using the conventional manufacturing processes to produce the dies. Next. So you can see the complexity, okay, jewelry design. Next. Yeah, direct tooling. Okay. Yeah. So you can see interesting thing here. This is spanner, adjustable, jaws. Okay, relative motion is there. Conventionally, what you do, you produce all these three parts you have to produce and then assemble them. Using the 3D printing, you can produce this entire thing in one go. No assembly, no part manufacturing. Everything will be produced in one stretch. Okay, still having the relative motion between them. Next. Yeah. So you can see the kind of complexity you can't imagine producing that using a conventional manufacturing process. Even the impeller blades. Next. So this is what we have talked about a little while ago about the mass customization. Next. So the prototypes for medical applications you can produce not just prototypes, the end user part parts also. Yeah. So you can see part of the skull you can repair also. Okay, when in an accident, if a part of the skull damages, then you can repair that also. So various things, you can see here artificial heart being manufactured. Okay, that is possible. Okay. Next. See, this bird has lost a beak. Okay, it has been repaired, and it was attached to this bird. Next. Of course, this is he's a crazy guy. He wanted his baby, which is still in the womb, okay, to be used as a keychain. Okay, that's a crazy thing. Next. So yeah, ornaments. Then you have sandals. Okay, using the 3D printer. Next. So you can observe here, British Airbus engineers aim to print out an entire aircraft wing. So if you are able to produce entire aircraft wing, then what else you can expect from a technology. And you can see here, IIT Madras, you might have seen in the news also. Okay, this was built at IIT Madras by a startup company. Okay, and one of the persons involved in this has joined our college also as a faculty some time back. Okay, so he is working here. So a single story house of 600 square feet was constructed. Okay, it is there in the IIT Madras Research Park. When you happen to go there, you can also see that. So constructed using indigenous concrete, 3D printing technology. Okay, the house can be built in just 5 days. Okay, so if you in future this may be very interesting. You leave, you go on a vacation or you go on a leave for some 4 or 5 days. When you come back, there is a house just behind, beside your house. Okay, which has come up in just 4 or 5 days. Very strange.
Material is concrete.
Concrete, yeah. Next. Yeah, you can have food manufacturing also using the 3D printer. Okay, even 3D printed meat. If you are animal lover, if you are a non-violent believer, okay, you can produce the meat without killing the animal. Okay, that is also possible. We call it cell culture. Okay, next. So you can print your own toothbrush of whatever design you want, depending upon structure, the teeth, all that. Next. So household applications, reverse engineering is very much possible with 3D printing. Next. So having given the rosy picture of 3D printing, we also have other side of it. Okay, there are barriers or challenges associated with the 3D printing. So mainly accuracy issues, finish, strength, material options. Okay, these are the some fronts. So accuracy, as you know, the part is built layer by layer. So obviously you will have this staircase effect on the components. Okay, unless you post process it. As such, there will be some staircasing effect, and that is going to cause the accuracy issues. Next. The finish, especially when you are using powder-based technologies, okay, and also sheet-based technologies, laminated object manufacturing, okay, such kind of processes, the surface finish is not so good. Okay, so your CNC machining process will be able to give you very good surface finish compared to 3D printing. Okay, so what I mean to say is that the component has to undergo post processing. Okay, in order to give desired surface finish for that. And when it comes to strength requirements, for example, you see here this component is built layer by layer in this fashion. Okay, when you load the component in this in this direction, it will have very good strength. Okay, and you see here when the component is built in this direction, when you load in the direction, then the strength between the layers is not so good, so it may get separated. Okay, in which direction you are going to load? Accordingly, you have to choose the build direction so that you will be able to overcome this difficulty. Next. So yeah, secondary operations are very much needed. In the post curing is required in the case of stereolithography. That is one of the technologies. Infiltration for fragile components. Infiltration means the components which are made in the using the 3D printing will be little porous. Density will not be so good. Okay, you just leave it. You just leave the component in a liquid bath. Okay, of some metal. Okay, so that this metal, liquid metal, will get into those pores and then increase the density. That is called the infiltration. Of course, final machining of the metal parts and also removal of the support structures, all these things fall under the post-processing activities. So you can see here, this is white material, this is the support material that is being removed. There are different techniques for removing the support material. Manually you can remove it, okay, or you can just leave that particular thing in a liquid bath, okay, so that liquid will be able to melt the support material without affecting the build material. Such a liquid you will have to use. Okay, just leave it there for some time, and then support material will come out. It will get melted. Okay, leaving the component without getting affected. So there are different techniques. So 3D printing versus conventional manufacturing. 3D printing cannot become complete replacement. That has to be kept in mind. Even though we spoke a lot about 3D printing, I don't say 3D printing will be able to replace the conventional manufacturing processes. It is not going to happen. Okay, you still will have the conventional manufacturing processes because they are good in certain conditions. Okay, this is good in a particular condition. When complexity is very high, then you will think of 3D printing. Simple component, go for conventional machining process or casting process. Very large bed has to be made. Bed you can't make using 3D printer. Okay, it is going to take a lot of time, resources. It will become eventually costly. Okay, instead your casting process will be able to give you cheaper component. So you have to weigh these advantages, disadvantages, and then choose. The final thing is judgment or decision making. Finally, that is what you will end up with, decision making. Which manufacturing process I should use for this situation, right? So that is important. So when you have the knowledge of all these processes or technologies, you will be able to make a right decision. Otherwise, you will just select something and which may be counterproductive, right? Yeah. So the 3D printing technologies are instead complementary for the conventional manufacturing processes. Okay. So complex or intricate geometric forms, whenever you encounter simultaneous fabrication of multiple parts into a single assembly without producing separate components and assembly, simultaneously you can manufacture that. Multiple materials or composite materials in the same part, that is where you can think of 3D printing, right? So that's
Yeah.
about.
So thank you for your valuable information. If you have any queries, and you can ask Professor. So we are on time, 12:10.
Yeah, please feel free.
Metal printings, what are the difficulties now in this case?
Metal printing, see, you have different technologies in additive manufacturing. Fusion deposition, okay, laminated object manufacturing, powder, powder bed, fusion processes, laser based. Okay, so it is not convenient to use all these technologies with metal. Okay, these days you are you see powder material being melted using laser. That is very well suited for metal. Okay, and of course in the case of another technology called wire arc additive manufacturing, that is where you will be introducing the metal in terms of the wire, and then you melt it, deposit drop by drop, and do that. Yeah, yeah. So you will have to the solidification allowances, all those things you have to apply. So today, as compared to plastics, metals, metal components are not very widely manufactured. Plastics, it is very easily done. using the present machines, commercial machines, all that. Metals, except using this technology, wire arc additive manufacturing, we have a setup. You can also see that.
We have a
This
lab.
lab visit is there. So otherwise, metal components, very small components you can manufacture. The challenge is it is going to take a lot of time producing the metal component. The time, it is time consuming. Okay. Yeah.
So in medical applications, what are the machines available in India?
Say medical applications, you have the commercial machines already being used. UOS machine you have, okay. You have the SLM machines, yeah. Those are commercial machines are available and you can use them. Of course, you have to ensure that it is made of correct material, biocompatible material, and also it will be compatible for that particular patient. You have to control the accuracies, the tolerances of the component that you are going to manufacture. So all these issues are to be addressed. Yeah. And people have to work together. People from medical fraternity and we the engineers have to come together, because the functionality aspects of the prosthetics they know better than us. Okay, and this side how to manufacture they don't know that. Okay, so people have to come together and carry out this interdisciplinary research. So the 3D printing is very much into the biomedical applications, and that is a very hot area. And workshop is on that thing, aptly kept by the organizers.
Sir, you told that functionally graded materials can be 3D printed, right, sir?
Yeah.
FGM materials.
Yeah.
So, is there a print screw extruder like that? It is there, no? Metal 3D printer. Based on that, two material, we have to vary the material property across.
You have to
the thickness.
vary the material quantities.
Okay.
You may have, let us say, 2 nozzles.
Yeah.
One, 2 nozzles will be, simultaneously depositing the material. One will be depositing one material at a higher rate than the other nozzle. That way you can control. So that you will be able to, maintain the gradient.
Okay. It follows the exponential gradient, or?
What is the percentage variation you require? It all depends upon the particular application. Accordingly, you have to set the parameters so that material A will be will be deposited at a particular rate compared to material B. So at what gradients you want to you want to build that, it depends upon that particular component application. Accordingly, you can set the parameters in the machine, control the material deposition. Yeah.
Sir, the argon gas is used direct laser energy depositions DLM process result. 2 chambers is there. Based on argon gases, the material will be flowing to nozzle cell. So, in my college PhD, now we are installing sir. And
Spoon preparation machine.
just we started
This
sir.
more
Actually, I have seen once there in Additive, but
Dr. Prabhan, robotics department, we are having the facilities.
As such, I don't have any
I need a sample.
contact or, yeah.
I need a sample for it.
There are very big players in the market manufacturing that one.
It is better you talk to them and give your requirement. This is how I want. Okay. Have this discussion with them.
Spool making is, wire, no?
yes, sir.
Wire making is not a problem,
Yes, sir.
but maintaining the diameter is a problem. See, there are people who can manufacture for 5 lakhs, 7 lakhs also. But the basic problem is that you have to maintain the diameter. So that for that one there is a LED system will come. So where the LED will come on both sides, and it will say where it is diameter is varying within. So for that purpose only the cost is goes exponential. You said no, Roorkee has a very costly machines. Diameter maintaining is very, because everything should be perfect, then only the things will come out. Then after that you have to cool it. Some people will do water cooling, some people will do lot of complications are there. That's why better is that get the spool for 1,000 rupees.
I mean, sir, no, if you want to customize
He
our,
wanted to customize
customize
the
the schools, like,
Customize means
I mean, if you want to change the properties, like,
A material composition
Material
what?
composition is there.
materials composition. Then you cannot change too much also because so each and every material has their own melting point. For example, if I want to do ABS, PLA, these type of things, then you have to choose within 10% or 15% of your melting point. Otherwise, it will begin. For example, if I want to do like temperature of, for example, ABS with PTFER, for example, high temperature polymers like. There are some, no, I don't remember that, which you use made biomedical, 400 degrees.
Peak, sir,
Peak. For
300.
example, peak and other thing you cannot do because the extruder for that is different, the extruder for this is different. So you can choose within the permissible limit. For example, one has 170 degrees, 180 degrees, 190 degrees. So you can mix all these things. So customization you can do.
Yes, sir. But in that, if you want to make a school,
There are companies like River Industries in Nasik. So they don't sell the machine. I don't know whether they sell the machine. They sell the River Industries is there. There are some other industries. In India, there are n number of industries are there.
And also the particular machine, 3D printer, is suitable for a particular materials. For example, one machine that we have in our lab here, plastic machine supplied by Stratasys, that can undertake PLA and ABS. The moment you change the composition, you are going to have issues. Okay. So machine compatibility is another thing that has to be looked at. When you
if
change
you-
too much.
But you give that material, it will print in a very fantastic way. Because that is specifically designed for that. So like, for example, industry, who want to do only on ABS or PLA, excellent machine that. So that's why you get the best machines. Stratasys is one of the good companies.
So when you do the customization for the spool material, corresponding changes have to be affected for the machine also. That is also important.
Okay, so if there those no questions, then let's thank the speaker. So,
I also thank all the audience, very patient listening and yeah,
so
thank you.
Thank you, sir.
Thank the speaker. Thank you, sir, for your valuable information. So, she is our international participant.
Oh, is it from which
So
place?
she is our student at IIT.
Ah, okay.
So from Myanmar.
Oh, okay. Good. Oh,
So
thank you.
we are not maintaining the ACP rules of 100 kilometers.
You have gone outside the country. Okay, good.